So I've got the part in the mill. I took the liberty to center it and do all that off camera so we're not wasting a bunch of your guys' time watching all that nonsense. Got to cut it 180 thousandths deep, 215 thousandths wide. This is a 3/16 end mill, which is 1/875. So it came out to 14 1/4 that I had to move off center each direction to get that slot to 215. I just went 14. We'll cut that because taking this deep of a cut, I'm cutting half of it the first pass. I'll cut half of it the second pass. This small mill bit's going to want to, because I'm going to be climb milling, which the bit's rotating around this direction. It's going to want to pull into the metal, so it'll probably end up with a little bit bigger. So hopefully we stay where the nipple will fit in there and be fairly snug, so we don't have a lot of slop. And it shouldn't be too hard to get the things out anyway once they're shot. So here we go. I don't know how sharp this end mill is. It's been used a little bit. It's the only other 3/16 end mill I have I use for my little boring tool. So we'll see how this cuts. We may have to pick it up to a lot less depth of cut to be able to use this and make it work. But we'll try it here and see how it goes. A little oil on it. I think that'll be fine. I'm going to go ahead and use the power feed. We'll just listen for noise and stop it if we get a bunch of rotten noise. Keep some oil on it. It'll smoke because we are cutting stainless. And our next cut is at 2.439. Back the other way. The only time that's really chirping is when it's right on the edge of the part. Once it gets into the middle, it sounded pretty clean and good. I apply the oil by just putting a little bit on the brush. Okay, so we're going to move back to the first cut, which was 2.411. I did not change and zero this y-axis out because right now I'm centered over the corner of the vise, and I don't want to change that zero, I have to re-zero the bit. So I just went off the dimensions that were written up on the screen then when I found center of the part. And I did turn the radius, or a little narrower diameter. I'm going to do on the bottom side, you can't see that in the vise. For cutting the hex, I'm going to cut a 3/8 hex on this to be able to put a wrench on it to get it in and out. So now we're going to go down to 180. It's too much. There's 180, 179.5 anyway, close enough. And back the other way. And back to 2439. Here we go. I went the wrong way. Done that more than once and screwed a part up. Left a big gouge in it I didn't like. Looks like my math might be off. It doesn't look like it's 215 wide. We'll see here shortly. close, but no cigar. Really close. So I'm going to take 2 more thousandths off camera. And get to where we fit. We'll pick it back up there. All right, so I just took 2 thousandths off of each side. Drops right in. And there's not really hardly any play in there. So now, let's turn it over. And I hope those edges are thick enough. They should be fine when they're inside the breech plug. They shouldn't flex out of the way. I think I'm going to quench this in oil also so that it's not quite as brittle, so it's a little more springy. Any event, it should be plenty to pull that out. All right, let's advance around to 0. Raise the quill up out of the way. Come down and touch. 0 the digital readout. And that's a 200,000th shoulder. So I'm going to come down 200 to cut these flats. And I don't know whether I ought to do it this small bit or switch back to the 1/4 inch one. I think I'm going to switch back to the 1/4 inch bit, just a little more oomph in there for making the cut. So let's pause and switch bits at 1.841. So if you take 2.154, that was the center. Up there you can see of the x-axis centered over the part, and you minus 125 thousandths. It's a 1/4 inch bit. That puts the edge of the bit over the center, and then you minus 3/16, which is 1.875. You came out with 1.8415. We're just going to do 1.841. Did I say that right? 1.8415, and we're going to cut 1.841. So patented sheet metal tripod. We're cutting 190 thousandths deep. It's a 200,000th shoulder. I'd like to leave a little bit of it on there, just for possibly aesthetics. If I had a round end mill, I'd cut it with that. That'd leave just the slightest little roll in the bottom of that hex, and that'd look pretty nice, but I don't have one, so here we go. We're at 0, we're locked in, and first cut. We're after 3/8. Advance 60 degrees. This one. That's to 120. Like that one. 240. And last cut 300. And there's our hex. Let's try a wrench on it, see if it fits. Three-eighths wrench. And that is snug. And the flat doesn't go on. So it looks like I needed that 1/1000th. See if I can measure that. Bring it back out of the way a little bit. And the trick is, can I find my calipers? I found the calipers. That's 380. 382. The small, no, 381.5, 381, 381. So we got to take 6/1000. So we got to go 3/1000. So I just moved the dang table without looking at what it was. So let me pause it and figure out where I was at. We'll cut 3/1000 more off of it. Actually, 1/1000. No, 3/1000 because we were 6 over. 1841. So I advanced 3 more thousandths to 1844. And here we go. I'm going to move this to back to 0 so I don't get screwed up where I'm at. And Now we'll try the 3/8 wrench. Goes on, but flipping tight. Box end goes on. But I don't like how tight that is. We're gonna go one more thousandth, and I'll do that off the camera. So I'm at 1844. Go to 1845. And just loosening the table gave me that thousandth. Oops. Go back to 0. Here's what I'm using to cut it. Just a little rotary chuck. I got it clamped in the vise. If you can see that for the light. Little 0 it. Loosen this little handle, pull this handle up, and you can roll it around. It locks in, I think, every 5 degrees. It's got positive, it's got detents in there that when you loosen this and roll it, it pops into a spot kind of similar to a miter saw. So anyway, I'll cut this last one. Hopefully the end wrench goes on there good, and we'll be done with this other than hardening it. All right, I just took that last cut. Now the wrench slips right on there. About the amount of play it should have. The box end goes right on. So I'm gonna just kind of dress those edges with a file a little bit and clean up the inside groove with a file just a little bit, and then we'll harden it. So we're gonna harden the Breechplug and the nipple wrench. I already hardened the nipple wrench because it would be too hard to do. I had to just kind of perch it on my little pointer stick here, which is made out of just a oxyacetylene welding rod. I sharpened up. I use it to clear chips out when I'm boring, and just kind of a pick, pointer, that type of stuff. Got the Breechplug sitting on a wire, torch sitting here. I'll try and do my best to keep it in the viewfinder the whole time. And there we go. This is just some used crankcase oil out of my old 1921 mill, which I sold. I changed the oil on it, and I've not taken the old oil to the recycler. I use it for stuff like this. So anyway, let's pause, get it all cleaned up, and see how we did. All right, so here we go. I really like what that oil did to that when I quenched it in oil. It was going to buff it off so it's all shiny, but I like that black. Dunked it in acetone, brushed all the oil out of it, and I like how that looks. I think I'm going to leave it. I think it'll look sharp with the stainless barrel, even though you don't really see it. And the same with the nipple removal tool. It's got a little bit of, carbon on the sides of it there. I'll brush it up a little better. Just kind of hit it quickly with a wire brush, a little hand brush. So, just put the nipple in it, see how it looks. There we go. We'll hold the breech plug with the 1/2" wrench. Nipple removal tool with the 3/8 wrench. And tighten it in here. There we go. I think I broke it. I did. I broke the son of a bean tool off. So we'll have to redo that if I can ever get it out of there. I don't know that I'll ever even get it out of there. Oh, that sucks. I thought quenching that in oil would make it so it wasn't brittle. That really sucks. Oh my gosh. We'll have to redo that. Hopefully I can get that nipple out. It's brand new. And I guess we better not try and harden it, because that just snapped. Cleaner than clean. Wow. I mean, that's about as clean a snap as you could ever see. I'll bet you that sucker's sharper than heck. All right, well, we'll have to cut it again. This time I won't harden it. All right, so I remade the little nipple removal tool. It wasn't bad. I had all the measurements written down. So anyway, there's the new one. I'm not going to harden this as of yet. I'll look up this particular still. It's just a drill rod I got off the master car. But I'll look it up and see what the correct process for hardening it and having it stay tough is. I figured quenching it in oil would take care of the trick, but as you can see, it wasn't anywhere near strong enough. So anyway, there's the new one. So I'm just going to run with it as is. The little nipples don't need to be tightened in too terribly tight either, just basically finger tight plus maybe a quarter turn or something. If even that. Threads are so small and the hole's so small, they don't tend to leak out around the threads. So anyway, that's a wrap on that one.